This lesson I'm going to talk about similar polygons. What I want you to think about with similar polygons, they're kind of like congruent polygons. If we think back to congruent polygons or congruent figures where my basic definition was same shape and same size. Now when you go to similar, my kind of basic definition would be they're going to be the same shape but probably different size. They could be the same size, but more times than not they will be different size. That's the basic definition. Now if you go to the actual mathematical definition, you look at, and the corresponding angles are going to have to be congruent. All of them. If it's a triangle, the three angles of one triangle are going to have to be congruent to the corresponding angles of the other. If you go quadrilateral, now you have four, so on and so forth. And we also have to have the corresponding sides have to be, notice this is not congruent, this is proportional. If they were going to be congruent polygons, the word proportional would say congruent. But being they're similar polygons, the sides just have to be proportional. Now, I'm going to take a look at two polygons here. And basically what I'm doing is I'm going to go through and I'm going to do the check. Are these two polygons similar? So the first thing I'm going to do is I'm going to check the sides to see if the sides are proportional. So I'm going to start off with by writing ratios for each side. Just start here with my larger quadrilateral. I'm going to work with segment ML, so I'm going to look at the length of segment L over. Now I have to match that up. And what we should have really done to start off with would have been look at the corresponding angles. Are they congruent? Well, I'd look at angle M and angle R. Notice I know my handwriting wasn't very good with this, but I have a 4 arcs with M, 4 arcs with R. Those two are congruent. Angle L, single arc, angle S, single arc. Angle T, double arc, angle K, double arc. And then last but not least, we have angle J and angle U have the triple arcs. So yes, I have my 4 angles matching up or being corresponding and congruent in the two quadrilaterals. Now back to our ratios. So I look at the length of segment ML, and the way I'm going to figure out which one it has to match up with the other one is I'm going to look at angle M, quadruple arc, angle L, single arc. So segment ML is going to have to match up with those same angles. So I look here, angle R has the quadruple arc, angle S has the single arc. This is going to have to match up with the length of segment RS. Now I'm going to look at, I'm just going to work my way around. I'm going to go with the length of segment LK. Angles again, single arc and double arc. In my smaller, what appears to be my smaller one, single arc and double arc would be length of segment ST. Then I'm going to go to the length of segment KJ. That's going to match up with the length of segment TU. And then last but not least, I'm going to have the length of segment MJ matching up with the length of segment RU. So those are my ratios. Now, to check to see if they're actually proportional, I'm going to continue on, and now I'm going to replace the length of segment ML and the length of segment RS with the actual numbers. So I'm going to have 20 over 5. We'll stay with black. 20 over 5. So there's the length of segment ML and the length of segment RS. Now I have the length of segment LK and the length of segment ST. So that's 26 over 6.5. 26 over 6.5. My next one, the length of segment KJ and the length of segment TU. 17 over 4.25. And last but not least, the length of segment MJ and the length of segment RU would be 12 over 3. So right now I look at these and I can't tell if they're proportional or not because all those numbers, I can't tell if those ratios are equal or not. So what I'm going to do then is I'm going to simplify each fraction. And if it's something you can't do in your head, use your calculator. It'll work. So 20 over 5 equals 4. You hit 26 divided by 6.5, you get 4. 17 over 4.25 is 4, and 12 over 3 is 4. Well, being these are all equal, that means that these are all equal, which means these are all equal, which means your sides are proportional. Now we already said that corresponding angles were congruent when we looked at this picture. I went around and matched up angle M and angle R. so on and so forth. And now we've just gone through and showed that the corresponding sides are proportional. Well, then I know my two quadrilaterals are similar. So what I want to do is I want to write that similarity statement. So I'm going to start off with quad. Now it doesn't matter. Well, to a certain degree, it doesn't matter what order we pick. I'm going to start with my quadrilateral on the left. I'm just going to start with M, and then I'm going to go L, K, J. Now we could have gone M, J, K, L, that's fine, but you can't go across the quadrilateral and say quadrilateral M, K, J, L. Start at one vertex and then go around either in a clockwise rotation or in a counterclockwise rotation. So I'm going to go quadrilateral M, L, K, J. Now this is the similarity symbol is similar to, and now quad. Now this is where it becomes important. M matched up with R. L matched up with S. K matched up with T. And then the only thing that's left is J matching up with U. When I want to say that these two quadrilaterals are similar, that would be how I would do it. Now realize we could have changed the order on this first one, which obviously would have changed the order on the second one. Next piece of vocab would be the scale factor. And the scale factor is nothing more than a ratio. Find two corresponding sides, look at their lengths, and write it as a ratio. You can write it as a fraction, which is going to be very beneficial. Remember that a fraction is a ratio. Now the thing with the scale factor that you have to realize is this. The units in those two have to be equal. So if one thing talks about inches and one thing talks about feet, like my next problem is going to deal with, you're going to have to convert those so that they have the same label. They have the same unit of measure. Now my one example dealing with the scale factor for now is this one. You have an architect prepared a 12-inch model of a skyscraper to look like a real 1,100-foot building. We want to know what is the scale factor of the model compared to the real building. Now remember, scale factor is the ratio of corresponding side lengths, and this is going to be in this case, similar polygons, or in this case it would be in similar solids. So it tells us that the model is 12 inches tall. It tells us the building is 1,100 feet tall. Well, again, remember I had to convert something. So I think it's going to be easier for us to turn the 12 inches into feet versus the 1,100 feet into inches. Now I'm going to use unit conversions. I know there's 1 foot in 12 inches. So really this is what we're doing, and I know this would probably be something you wouldn't need to actually show your work on, but I'm going to show it just in case. I like to do this because now I can see very quickly that my inches are going to go away, and it's very easy for me to see that feet will be my label, because that's the only label that's left. My 12s are going to divide out, and I'm left with 1 foot. So another way to look at this 12-inch model is to look at it as a 1-foot model. And now I need to write what is the scale factor of the model compared to the real building. So notice it says model to real. Well, start with your model. We know that that's now 1 foot tall over the real building, which is 1,100 feet tall. What I want you to look at here now in this scale factor, the labels are going to be the same, so my scale factor comes out to be a number with no units on it. Scale factor of 1 to 1,100. That's going to conclude the lesson part of this. I will also have another video dealing with some more examples.